Hello, primary 6 students. How are you? This is your time to study science, as now we will study lesson 3 from concept 1, unit 3. This is me, Shaimaa Hamdy, and you are watching the Big Sister channel. So don't forget to subscribe, like, share, and press the bell button to get all the new notifications. Now we have activity 6, energy transfer and water cycle. Are you ready? So let's start. First, we know that water is important. Yes. Why? Yes, as human needs to drink water to live and survive. Also, animals need water to live and survive. As you see here, some examples for animals that need to drink water to live and survive. We have giraffe, we have elephants, lion. So, also most plants depend on rain that falls from the clouds in the sky to grow. So most plants depend on rain that falls from the clouds in the sky to grow. Okay? So this is the importance of water. So let us move to the water cycle, okay, in nature. So what is the importance of the water cycle in nature? First, water cycle provides water to all living organisms. And the second thing that the water cycle do is it regulates the weather on our planet Earth. Yes. So the water cycle provides water to all living organisms and regulate the weather on our planet. Okay, so the importance of the water cycle in nature provides water to all living organisms and regulates the weather on our planet. So nature recycles water. Okay, how it comes as water found in nature, and nature recycles water. The word recycle means that the water evaporates from the Earth's surface, okay, and then it forms clouds and rain falls and water come back to the Earth's surface. So this is recycles, okay, and this is the water cycle. As a water cycle include what? Yes, continuous movement, as this is all the time happens, that the water evaporates and then condenses and precipitation happens as rain falls on the Earth's surface. So this is a continuous movement. So water cycle includes the continuous movement of water from the different resources, okay, as oceans, seas, rivers, okay. Water evaporates from these resources, okay, to the atmosphere in a form of water vapor. Then water finally back to Earth in the form of rain or sleet or snow or hail. So this is how the nature recycles water, okay. I hope this point is clear, okay. So do you remember the processes in the water cycle? Yes, very good. We have 3 processes, yes. Evaporation, condensation, and precipitation, yes. And we have 2 steps after the precipitation. Yes, the 2 steps are runoff and collection, okay. So we have here an important question. Give reasons for the total amount of water doesn't change even if the water changes from one state to another. Why? As here we have the water changes from liquid to gas, as in the evaporation, and in condensation it changes from gas to liquid state. Even this happens, the amount of water doesn't change. So what is the reason? Because it can be replaced or recycled through the water cycle. And the meaning that evaporation happens, and also condensation and precipitation that keep the amount of water constant on the Earth's surface, as the amount of water doesn't change, okay, on the Earth's surface. So again, here is what? Yes, the water cycle. We have 3 processes, as the first process is evaporation. The heated liquid water over oceans, lakes, and rivers evaporates and change into water vapor. Yes, and then the second process, we have condensation, as the water vapor rises to the atmosphere, then it cools and condenses into water droplets in the form of clouds. Water droplets, very tiny, small drops of water. Okay, so now here we have water droplets that form clouds. Okay, then what happens? The third process, which is precipitation. The water falls to the earth surface in the form of what? Rain, sleet, and snow, or hail, which is snow pellets. Okay, and here we have 2 steps. Yes, so we have runoff, as the water flows along the earth's surface into rivers and then into oceans or seas. Okay, as the water flows to the rivers and oceans and seas, so this is runoff, as the water flows, okay, on the earth's surface. And we have a second step, which is collection, as water collects in streams, rivers, lakes, or oceans. Then it evaporates again, and so on. This is a water cycle, continuous movement of water. Okay, so this is the water cycle. We have here a new expression or scientific term, which is convection. Convection. As convection is a type of heat transfer. As you see here, what you see here, yes, here there is movement of water, yes, while it boils or heated. Why? This is what we will discuss as convection. Okay, as you see here, the definition of convection: it is a process in which heat transfer in liquids and gases. So liquids like water, gases like air. Okay, where the hot molecules, molecules is small particles. Okay, so these hot molecules which have less density, so they are lighter, okay, now rise up, okay, and the colder molecules, okay, that has more density, as they are heavier, they will fall down. So as you see here, it looks like something go up and other replace it. Okay, so this is convection. The hot molecules rises up because they have low density, they are lighter, so they rise up, and the colder molecules falls down as they have high density, they are heavier. Okay, this is what we call it convection. So again, convection, it is a process in which heat transfer, as it happens when there is a heat. Okay, so this heat transfer in liquids and gases, where the hot molecules which have less density, they are lighter, rise up, and the colder molecules which have more density, they are heavier, fall down. Okay. So here, this is the word convection. Okay, as we mentioned that convection is a heat transfer in liquids and gases, so we can see the convection happens on Earth when the heat of the sun transfers, okay, from the space into the Earth's atmosphere. Okay, so heat of the sun transfers from the space into the Earth's atmosphere by radiation. And radiations mean it's a type of energy, okay, that travels through the space, and it has the speed of the light. Okay, so this is radiation. And the heat from the sun can transfer through Earth's atmosphere also by convection. Okay, convection. So again, this part, as heat of the sun transfers from the space into the Earth's atmosphere by radiation or by convection. And now we will talk about convection. Okay, so the heat can transfer through the Earth's atmosphere by convection in form of convection currents. As you see here, this is the convection currents, as air warms and rises up, okay, because less dense, as it is lighter, so it rises up, and colder air will replace this as it will fall down. Okay, so and so on. This is the convection currents. Okay, here another picture that shows us the convection currents, as heat transfers to the air, so the air warms and becomes less dense, so it rises up, and a colder air which is heavier, it has high density, so it falls down. So what we understand that convection happens, it is a heat transfer that happens in liquids and gases. And liquids like oceans, the water in oceans and rivers and seas, and in gases like the air in the atmosphere. So when the sun heats the land, okay, and ocean, and there is unequal heating for this land and ocean, that causes what? Difference in temperature, okay, as we have warm molecules and cold molecules. So and the warm molecules have what? Low density, lighter. They are lighter, okay, and the cold molecules are heavier and have high density. What causes this difference in temperatures and densities? The unequal heating of land and ocean. The unequal heating of land and ocean causing the difference in temperatures and densities in water, ocean, and atmosphere. Okay, as we see here, if we have liquid or gas molecules like that, when they are heated, what happens? They expand. They are less dense. They are lighter. They rise upward. Okay. And if we have a liquid or gas which is cooled, okay, what happens? They become more dense, heavier, and fall down and replace the warm liquid or gas. And this what we call convection current. Okay, I want you to know that the force of gravity helps in rising up and falling down of different densities of liquids and gases, as the gravity has an important role here in helping the rising and falling down of molecules, okay, of gases or liquids. As you know that the force of gravity pulls the objects, anything toward the Earth's surface, yes? So it pulls the heavier molecules, which is cold molecules, to the Earth's surface, okay? And when these cold molecules is heated, so it become lighter and it rises up and so on. So the gravity has an important role here, as it leads to rotate the convection currents, causing the formation of wind and ocean currents. And this movement form the wind if the air is go like rising up and falling down. So this is the formation of wind. Also, we studied in the first lesson, I think, that the wind causes the ocean currents, okay? As you see here, also we have here the ocean currents, and this is a map of the ocean currents. And we have here an important note that the convection currents in Earth's atmosphere help in determining the regional climate. What is the meaning? As the movement of the hot molecules and cold molecules causes what us to know the regional climate, okay, the climate in different places, okay, regions. How can we determine the regional climate? As you remember what we said in lesson 1 part 2, as we have 3 main regions on the Earth's surface, as we have the hottest region and the moderate region and coolest region, yes, depending on what, yes, the amount of solar energy that reaches to the Earth's surface, different from one place to another, as the region that gets a large amount of solar energy, yes, this is the hottest region, okay? So, and the region that gets less solar energy, this is a moderate region, and the region that gets the least amount of solar energy, this is the coolest region. The convection currents help us to determine these regions and the climate in these regions, the regional climate. Do you know why? Yes, because the convection current depends on the heat transfer. If there is place or area that has more heat, so there is warm air rises up and cold air replace it, okay, and we will know that this place is very hot region. This is, for example, to know what is the relation between the convection currents and the regional climate. Okay, here we have the last part we have today, the relationship between the convection and condensation. Okay, as you know, the definition of the convection process in which heat transfer in liquids and gases as the hot molecules rises up and colder molecules fall down. And the condensation is the process in which water vapor changes into water droplets due to cooling. Okay, so because of the convection is heat transfer, so it causes the rising of temperature, yes, of air that contains what? Water vapor. So here the convection causes the rising of temperature of air that contains what? Water vapor. While condensation is the opposite. It's about cooling, as when the molecules lose energy. So this is condensation. So if we talk about the water vapor in the air, so in condensation, what will happen? When the rising water vapor loses its heat and the cold water vapor changes into water droplets, that leads to the formation of clouds. Okay, again, this part, as we know that the condensation is about what? Losing energy, cooling. So if we have a water vapor that rises up, okay, this water vapor loses its heat, okay, and it cools, okay, and this cold water vapor will change into water droplets that leads to the formation of clouds. With this point, we finish this part of lesson 3, and we will continue in another videos. So thank you for watching. See you next video inshallah, and goodbye.